Am I audible to you? Can somebody respond?
Yes, sir.
Okay, so in the last class, we discussed about Git installation, right? And then we also discussed about on-premise repository and then creating repository in GitHub. So as we discussed in the last class, we create the repository in GitHub, okay? So assume that this is your GitHub. This is your GitHub. Somewhere in GitHub, we create the image. Sorry, we create the repository. This is your remote repository. Remote repository. Let's see how we can create this remote repository. Assume that this repository name is, say, faculty, okay? Some name you can give, usually the project name. So once you create this repository, then we'll get one URL for our repository, and we give this URL to development teams and creatives, and then they clone that repository and then they do their work. Let's see how you create this repository. You know that end-to-end build and deployment workflow, right? Just in case if you forget to link. So this is your GitHub. So as we know, developers write the code in their laptops. They place the code in GitHub here, correct? Then we clone the code. We build the application using Maven, and then we deploy the application into Tomcat server. This is your Tomcat server. And anybody can use this Tomcat server name. Okay, so name is say flipkart.com. So the moment they type that in the browser, it will come to this mission. Here you have the code, compiled code, and then server is running, server executes the code, and then it sends response back to the browser, correct? And we are talking about this. So how do you set up this repository? And then how you work with this repository? We are learning those commands. So if you want to create a repository, you have to go to github.com, okay? So I'm going to github.com. So this is your github.com. Before you create the repository, you need to first create an account, okay? So if you want to create an account, you know, right? Just go here. You want to create an account, type github.com, sign up, okay? And then you can give a username and everything, and then sign in. So this is my username and then password. I have the two-step authentication. Okay, this is my GitHub. I'm inside my GitHub. Okay. Now let's create a new repository. So if you want to create a new repository, click on this button, okay? New. I'm explaining how you create your own repository. So once you create your own repository, then you know how to work with it. So if you want to create a new repository, click on this new. Then this is your username, okay? Give a repository name. I'm giving something like, faculty. That's my project. It says repository name faculty already exists in this account. Just to make it different, I'll use something like this, okay? right? Okay. Assume that name is faculty. You can give some description, okay, for your project here. Online learning platform, something like this. Then you have two options here. One is private, one is public. You can have either private repository, you can get either private repository, or you can get public repository. You have two options. If it is private repository, assume that this is a private repository. If it's a private repository, nobody in the world, without your permission, okay, without your permission, nobody in the world can clone the repository. They cannot even clone, they cannot even see the code because it's a private repository. If somebody wants, you have to give permissions to that person. That's about private repository. So if the private repository, nobody can see the code, nobody can modify the code because they can't even see, so they cannot modify it. You can also create public repositories. You can also create public repository. If it is a public repository, anybody in the world can clone because it's a public. Anybody in the world can clone, and then they can see what is there in the repository. They can see the code, but they cannot modify and then they cannot push without your permission. Even though it is a public, right? People cannot modify without your permission. If somebody wants to modify, they have to take your permissions, but they can see. That's the difference. So at the time of creating the repository, right, you have to select whether it is public repository or private repository. So here, like, I'm creating public repository. If you want private, just click on private also. There is no difference. Okay. So let me create a public repository. Okay. That's all simple. So what you have done, you have given a repository name, some description, and then public or private, and then just say create. Click on create repository. Your remote repository is created, and this is the URL of your repository. See how simple it is, right? And how easily you can create a repository. That is the advantage of GitHub. I said GitHub is also an application, correct? It's an application. Application means this is application. GitHub is an application. I'm accessing GitHub application here. I'm accessing GitHub application. Since it's the application, by clicking, few things, new, give the repository name, select it's a public or private, and then just say create repository. Repository is created. How easily you are able to create the repository? If it is your own on-premise server, you may have to write, you may have to execute multiple commands. So here, since you have the repository in GitHub, user can very easily work with Git, right? GitHub is a GUI. It's an application, you can say, okay? And it's also a cloud where you can create your own repository. You don't need to manage. If it is your own repository, you need to have a backup. No, you need to take a backup, system administrator, network engineer. You want to have some database expert, a lot of things. So that's the reason usually we don't go with on-premise. We mostly create the repository in GitHub. You can create the repository in GitHub. GitHub is a business, okay? That's their business. They say, you come create a repository with us, right, in our server, and you pay for our service. So it is very cheap. So $7 per month. Likewise, you have GitLab. You can go and create your repository in GitLab. You can go and then create your repository in what? Bitbucket. So you can create the repositories in any one of these cloud providers. So GitHub is more and most popular. GitHub is very popular. Clear? So that is the difference between Git and GitHub. Git is a tool. Whereas GitHub is an application. Okay, it's a cloud and then it is application. What happened? It's crashed. So this is your GitHub. In GitHub only, we create the repository. We just create a repository with the name by Culti. Okay. Remote repository. Clear with this? Now, earlier I asked you not to remember the repository URL. Now you remember it very easily. https://github.com. In github.com, this is the username. Okay. You are in github.com. This is your username. This is your repository name. T69.git. Remember, remote repositories, Git remote repository URLs always end with .git. Now, shall we clone this repository? Imagine that it's a small company, it's a startup, and I know you have some team members, and people came to you and then asked you to create a repository so that they can all push their code to the repository. You have created the repository, and then you get the URL, right? T69.git. Now you give this URL to your team members, saying, I have created a remote repository. This is the URL of the remote repository. You can go ahead and then modify your code. Okay. So let's see how your team members, right, project members, work on this repository now. Shall we clone the repository, everybody? Can you tell me the URL? HTTPS :// what's that?
GitHub.com.
GitHub.com. Your username. Try to remember my username. Then comes
Repository name.
69.
It's a typo in HTTPS.
Yeah, HTTPS. Okay. So I'm cloning the repository now. And we know there is nothing in this repository. It's a empty repository, correct? We don't have anything in this repository. Let's clone it. Enter. See, it says, you appear to have cloned an empty repository. We know this. There is nothing. Ls. Guess what will be there? When somebody clones the repository, they get a folder here, right? Which is matching your, matching your repository name. T69. See here, this is the folder. And so the folder, you'll be having .git, we know this. And we have source area, and then we have staging area. And there is nothing in this particular remote repository here also. You won't be having any application code. See this. Let's go to this directory. ls. ls-a. A means all. It will show you the files and folders which start with dot. If a file or folder is starting with a dot, we call that as hidden file or hidden directory. Okay, so we are so we have .git. Okay, this is your .git. This is your .git, and we don't have anything in the source area. This is source area, right? That's your source area, and we don't have anything in the source area. Empty. You have only one .git. There is nothing here in the source of the staging area. Okay. Shall we add a new file now. Okay. Say think that I'm a developer now. Okay. So developer has cloned the code, and then developer is working on this particular repository. And where do we do our work? In the source area, right? So I'm in my source area. ls-a. Okay. There is nothing. I'm a developer, and then I'm creating a file. Any questions so far? Okay. So I'm creating a file. Okay. I'm a developer. When you practice, you can do anything. Okay. Just say login.txt or whatever. You're not learning Java here. What we are learning, if at all you have to modify something or create a new file, how do you modify? How do you push it to the remote repository? Is what we are trying to learn. So when you practice, just take some text file, Java or whatever. Okay. So ls-a git status. You can run git status command any number of times. It will tell you the status of your files. It says you have one untracked file. Untracked means it's a new file. Tracked file means if a file is already present in Git, that means it has a tracking information, right? Who modified it, what time it is modified, why it is modified, and so on. Since this file is new, it declares it as untracked file. Okay, now we all know, right? We just created a file called login.java. Now we have to add it to the stage. Then we'll have to commit it. So the moment you commit, what will happen? Tell me. Git will store that particular file in the local repository, correct? It will store the file in the local repository. It will give a version to it, correct? And then it will also store who modified it, what time it is modified, why it is modified. So let's add it to the stage. Git add login.java git status. Earlier it was in red color, that means it is in source. Green color means it is in staging area. Okay, remember that. Git status. Now I'm committing it to local repository. Git commit, and it will store the reason also, right? Why you are committing this. So Git doesn't know the reason. So we have to give the reason in double quotes. It's a, I'll just say login module code goes here, something like that. And then you can give the file name. Now change is committed to local repository. Proof. That means you have a commit here. You have a commit. Let's see. Can somebody tell me how you can see the history of this particular login.java? What's that command we use? Git log. Why we see this? So who modified the file? What time it is modified? Okay. Then why it is modified. So whatever message we have given, commit message, same thing is recorded here. And this is how the number looks like. So here I'm using 1, 2, 3, 4, but in real, it is something like this. We'll talk about that number later. Similarly, I'm creating another file. For example, form.xml. Okay. So I'll write something like this. Don't worry about the code, okay? When you're practicing, just write something like this, right? ls-a git status. Okay. Now it says there is a new file. I want to commit it. Git add, git commit, -m, some message, okay? Build automation code, form.xml. Now I have two files, okay? Git log form.xml file. This file is, this file has only one. So now you create another file called form.xml file, we add it to the stage, and then we commit it. So in the second commit, form.xml file is there, and this also is there, okay? Login.java is also there. So second commit will be having the first commit also. So for example, now you do git log. You have two commits in the repository. If you want to check the exact log of a file, if you want to check log of a particular file, history of a file, you say git log and then file. If you want to check the complete repository history, two commits we have. So one is this, and then second one is this. ls-a. Okay, right. So we have two commits, two files in our local repository. Now, the moment you push it out, and tell me, the remote repository, you have the first commit, you have the second commit, pom.xml file, and then login.java. Assume that this is 1, this is 2 number. Okay. So both will be pushed to the remote repository. Now, what is latest? Latest is 2, right? In 2, you have 2 files. From now on, if anybody clones the repository, they'll be having the first commit, second commit. Second commit has 2 files, login.java and then pom.xml file. It will give login pom.xml file. You can modify. It will show you 2 in the source area. It will give the latest here. Let's push it to the remote repository. Git push. Now these 2 files are pushed to remote repository. Okay. Now you can go here. We are using GitHub application, right? So you can see everything here. Just refresh it once. 1 second. That's right. Yes. Okay, so if you see here, you have 2 files, right? One is login.java, you see here. Second one is pom.xml file. So now you have 2 files in remote repository. 1 second, I'll take your questions. I'll remove this, my local copy, okay? Assume that I don't have anything. Assume that I don't have anything. So I'm a new user now. Okay, you have 2 files in your remote repository. Now, if anybody clones this repository, what do they get? Git clone https:// github.com/nageshweekend/vitality 69 git. Yeah. There is a folder 69 ls-a. This time you have 2 files in remote repository. 2 files it is showing in the source area. So you have 2 files here. Clear with this? Any questions you have so far? Okay. Now, assume that I want to modify some existing file. I'm a new user, okay? Think that, say, somebody, Ram, for example, right? Git status, no files are modified. It says, nothing to commit, working tree is clean. That means you don't have any modifications. Now, I'm modifying the file, okay? So I'm a developer. I open some existing files. I'm adding some code, okay? Public class, class. Don't worry about the code, okay? When you practice, just type something. Git status. It says this file is modified and it is in the source area. It is not telling that it's an untracked file because it's an existing one, right? You're modifying the existing file. So likewise, you can run status command any number of times. Assume that I modified 20 files. Assume that this project has 1000 files. Okay, project has that. Assume that this file, this project has 1000 files. Okay, and you modified 10 files today. You went out and then you went out for a coffee and then came back. How do you know how many files are modified? Do you remember? 1, 2, you may remember. What if you modified 20 files to fix a bug or 20 files you modified to develop some feature. In that case, use git status. Since we are storing the code inside the gate, right? Git is a tool, right? So Git knows what file you modified. It is clearly giving you, okay, you modified this file, this file, this file, so on. If you store the code in a normal folder, you store the code in a normal folder, can you use commands? And can you list the files which you have modified? No, right? See the advantage of storing the code in Git. Okay, you can store. I mean, if you store the code in Git, you get all these advantages. Fine. I modified a file. Okay, so then I want to commit and then push it, right? Git add login.java, git commit -m, and then something. I know I modified the file. I know why or what I have modified. Something like this. Okay. Git login.java. See this? This particular file has been modified now 2 times. This is the first one. This is where we created it. This is where we did something. Okay. It has 2 commits. So Harry modified this particular time. This is the reason. For example, if Sally modified this, it says Sally modified this particular file at this time. This is the reason. If this particular file is modified 1000 times, you will be having 1000 copies of it. This is Harry's copy. This is Sally's copy, and so on. And this is the latest. Clear with that? Any questions you have so far?
So let's say if we are updating 100 files, so then how we will commit it together?
Okay, say this, everybody. Assume that git status, I don't have any modifications. Okay. Assume that you've modified multiple times, multiple files. Okay. Login.java. Here, I'm just adding something. Okay. Right. Git status, modified one file. I'm modifying another file. Okay. I'm just removing something here. Two files are modified. ls-a git status. See, it is telling you that you modified 2 files. Modified. So now we have to commit and push it, right? So if you want to add it to the stage, usually we say git add login.java form.xml file, file 2, file 4, and so on, correct? What if you modified 100 files? Do you need to give files a name, file names one by one? Not required. If you want to add everything, instead of giving the file name or file names, just say dot. Dot means all. Dot means current directory, right? So that means whatever files you have modified, everything will be added to the stage. See, both files are added to the stage. Okay. Was that your question? Now, one second. Again, we have to commit all. Git commit -m login module code changes to fix bug 1, 2, 3, something like that. So usually we give the file name here, right? Login.java, foundation file, file 2, file 3. You don't need, okay? So at the time of commit, if you don't give, remember this everybody, I'm committing, okay? If you don't give any file names here, it will commit everything that you have in the stage. In this case, I have 2 files in staging area. All 2 files will be committed. You don't need to give the file name. Status. Now we have 2 extra commits in your local repository, which are not pushed to remotely. Clear with this? Any questions? Okay. So I have given all the steps here for creating a remote repository. Log into this, click on new, click on that, and things like that. You can follow this and then create a repository. Once you create the repository, create a sample file, add it, commit it, push it. Okay. And you can check the history of the file that you have modified using git log. Okay. Fine. So I'm pushing these changes to remote repository, right? How do you push? Git push correct. When you push the changes to the remote repository, it will ask username and password. As I said, if it's a public repository, anybody can clone. Yes, anybody can clone, but anybody cannot just go and then, push. It's a free public repository. Doesn't mean that you allow anything, everything, right? Correct. You don't want to, correct? But if you allow, people will just randomly go and then take out your code or modify something, and they create a lot of issues there. So when you push something into the public repository, it will ask username and password. Okay, username and password. In my case, my credentials are already stored in this mission. In this mission, my username, my GitHub username, password is already stored. So that is the reason it is working. Okay. So in your case, you have to generate the password. So if you want to generate password for your repository, go here. Again, all these steps are clearly mentioned in the notes. Setting up token or password to access GitHub. So this is how you can set up your password. Okay. You have to generate it. If you want to generate the password, see, ID is your GitHub ID, but password is not your GitHub password. If you want to log in to GitHub, you will use your ID right here, Nagesh VKN. Correct. I'm signing in now. So I'm signing in and I'm giving the password. Right? You cannot use this password for pushing your code. Okay. This is for you to, this is for logging into your GitHub, not for pushing. Remember that. So how do you generate the password for pushing the code to the remote repository? Just observe. I have given all the steps in the notes. You can follow the notes. Click on this user icon. Go to settings and then go to developer settings. Personal access tokens. Don't try to remember. The steps are there in the notes. Click on classic. Click on generate new token. Classic. You can give some name, something like this. You can set expiry date for your password if you want. Okay, I'll just say no expiry, or I'll say 30 days. Click on the first checkbox. Okay, this will give you the complete control. Don't touch others. Generate token. That's all. This is my token. Okay, I'm copying it. So copy that and then save it somewhere. I'm saving that here. Okay. That's how you generate token. Clear with that? So if you want to push right today, after the class, you will create your own remote repository, right? So once you create the repository, you have to practice modifying the code and then pushing and all that stuff, right? So if you want to push, you need to have a token, correct? So this is how you generate a token. So use your GitHub user ID and then token that you have generated. Clear?
Hey, sir, we cannot customize that token according to us. Or every time we have to remember or we have to have a copy of that token.
You can permanently store this token, okay, in your machine. I'll show that to you. Okay. See this before that, everybody. Now, let me show that to you, okay? So I said my credentials are already stored in this machine, right? Correct. Let me remove my credentials. It stores the credentials here. You'll understand about that file later, don't worry. Okay, I'm in my repository. Okay. I'm modifying some file. Assume that I've removed something. Git status, git add, git commit -m, remove some gen characters. Okay. You can give file name, or if you don't give file name, whatever you have in the, git status, it is in staging, right? And if you want to push it, commit, sorry, if you want to commit -m, remove some gen chars. You can give the file name, or if you don't give anything, whatever you have in the staging, everything will be committed, right? Commit. Now we say this. We encountered one more issue now. This is the error you will get when you commit into the remote repository first time. For example, I'm committing something, okay? I'm committing something into my local repository. When you commit, it'll record some extra details, right? Who modified, what time it is modified, why it is modified. So it tries to take the name, your name from your mission. It tries to take your name from your mission. And it also needs email ID, right? It also needs email ID. So first time when you commit, you have to give your username and user email. You have to set up your username and user email. Since it doesn't see, it will try to take the username from your mission, and then it will try to take this email ID from your mission. This is your username. This is your mission name. Okay. Who am I? This is my username. I logged in as a parallel user. And if you take the name of the mission, this Linux mission name is Vitality. So automatically it is taking my username at the rate hostname here. But the hostname doesn't have com. And the email ID should have vitality.com, right? Since there is no .com, right? It says this email ID is not valid. Otherwise, if the hostname had vitality.com, it would have taken it. Okay, leave it. Even though it tries to take the username and email ID, from your machine. Most of the times we don't want this name, we don't want this email ID. So it says you are committing fine, but I have to record who is committing. Please tell me who you are. I'm trying to construct, but I'm unable to construct the email ID. So tell me who you are. So configure your username and email ID is what it says. Shall you configure the username before you commit something into the repository first time? You have to, configure your username and email ID. If you have to do that, hello git. So that is the error, right? If you have to configure, you have to tell git hello git config. Please configure username, user.name. This is my username. Git hello git configure username, and this is my username. Git config username. This is my username. Okay. And I am adding something called -- global here. -- global means use this username for all repositories. You may be working very rarely, okay? You may be working for multiple projects, right? So you will clone one project in this repository, in this mission. You will clone another project in another place. So what I'm telling here is, if I am using git command in this mission, no matter which project or which repository it is, use this name for all. Global means for all repositories. You don't need to remember, but for interview sake, you have to. Whatever it is giving, I'm just copy pasting it. That's my username. Then email ID. Email in brackets email ID. This is my email ID. Okay. Now my username and email ID is set. If you want to check all your configurations, you can use a command called git config -all. Sorry, -list. Git config -list. See, it is giving the username and email ID. These are the configurations you have done just now. And there are some default configurations related to Git. Don't worry about them. So today we learned setting up username and setting up the username and email ID. This is the topic. Okay. Setting up mandatory configuration. Mandatory. If you don't, set your username, email ID, it will not commit. No, because it has to record, right? It has to record. If it doesn't take from you, then people will blame. It says you have to give your username and email ID, commit message. If I don't record, then people will blame me tomorrow after 10 years. So I will not allow you to commit. So you have to configure. Do you need to configure the username and user email every day like this? No, only once. Okay. You need to configure your username and email ID only once. So first time when you execute these two commands, Git stores all those things here in your user home only. There is a file called .git config. Remember this file. Git configurations are stored in this file. .git config. Open this file. See, it has stored your username and email ID. It says you can directly create this file also, but we have to follow the syntax and everything, right? We don't do that. It says you just use the commands like this, email and then username. I will capture the details and then I will store the details in this particular file. So every time you commit, Git reads your username and email ID from this particular file and then it will use it. So you don't need to configure username and email ID every day. It's only one-time task. Okay. See this section. Username, user email, git config -FN list. It lists all the configurations, and Git stores all configurations in below file. Where is that file? Username, dot git config. So question, okay? Interview question. Can you tell me where Git stores all its configurations? Say user home dot git config. That's a file. That's how you set the username and email ID. Clear with this topic? Any questions about this? Okay, now, so let's commit our changes. We have some modifications, right? Git status. We have found as well. I'm committing it now. Git commit -m removed junk chars. Okay, form.xml file. See, commit is done. Because username and password is set, right? Git log form.xml file. So first commit, second commit, third commit. So this is where we created the file. We modified something in second commit. Again, we modified something in second commit. So this particular file is modified 3 times. So since we have already configured the username and email ID, we are able to commit. If there is no username and email ID, it will not allow you to commit. Shall we push this to the remote repository now? Git push. See, it is asking for the username. Okay. So if you want to commit something, right, you need to have that username and email ID set up. That's a one-time activity. If you want to push, you have to give your GitHub user ID. This is my GitHub user ID. And then the token, we have generated the token, right? We generated the token from here. So give the token. This is where I have my token. Copy. So this is not your GitHub login password, okay? You have to generate the token, paste. Sometimes people ask me, sir, I have pasted, but no, nothing I see. It's a password. It will not show you, okay? But it is pasted. Just enter. See, we're able to push it to the remote repository. People do one more mistake here, usually, okay? I'm in Linux machine right here. I'm in Linux machine. So you save the token in your Linux machine only. Open the browser in Linux machine, generate the token here, save it in your Linux machine only. Okay, somewhere, like something like this. Save the token here. Sometimes what people do, you are working in Linux machine, right? But they save that token somewhere in your Windows machine. And okay, you have the token generated and then saved in Windows machine. Okay, you have saved it, but you copy like this. You're copying something from your Windows and then you are pasting it in Linux machine. Won't work. You cannot copy something from Windows to Linux by default. Okay. If you want, you can enable that somewhere. It should be in Oracle Log settings, but copy paste by default don't work. Since paste is not working, it's a wrong token, right? So push won't work. So make sure that you generate the token. Do whatever you want. You generate it anywhere, but the token should be saved in the Linux machine so that you can copy paste it. Clear? Now, how do you save my password? Right? When it's a push, it is we have to give the token, right? Always you call it the password or token. We have to give the token, correct? So how do you save it? If you want to save your token permanently, you can use this command. Credential.helper.store. So you have to tell Git, okay, hello Git, configure global for all repositories. Okay, git config -f global. So this is the key, okay. Credential.helper store. Remember this. Credential.helper store. So this you're configuring, okay? You're configuring your token to be saved permanently, okay, for all repositories. You may be working for different repositories. Hello Git, please configure credentials to be stored permanently, okay? So you have to remember this, credential.helper store. If you execute this command, then it will store the credentials permanently, okay? Let's see if it is permanently stored. I'm adding some file. I'm modifying something. Git add, git commit, -m, bad commit message. You cannot give commit message like this. No. If you give something like this, tomorrow if somebody wants to understand something, right? Why that file is modified, what is happened there, people don't understand. So that's a bad commit message. Git push. Git push. See, we have asked Git to store the credentials, right? It will store, but first time you have to tell, right? First time you have to tell. Next time onwards it will store. So once you execute this particular command, it will ask once. Second time onwards it will not. So now it will store, okay? We have configured Git to remember the password. So we have to give first time, right? So first time I'm giving a password. It's saved now. Next time it will not ask. I'm committing again. Git status. Git add login.java. Git status. If I want to know where the file is, I can run git status, any number of -m. Git push. Is it asking? No. That's how you store your credentials. Credential helper store. I've given that command here. Clear with that? Any questions you have for me? So what you have to do before tomorrow's class? Creating remote repository. You have to create an account in GitHub. Create your own repository. Okay. Clone your own repository, right? Using clone command. Add some file, commit, and then push. And then check if it is pushed to the remote repository. And if you want to push, you need to have a token. Okay. Generate the token. And before you commit, you have to set up your username and then email ID, right? So you know how to do that. Set up that and then commit it and then push it. Clear? Any questions? First time. Okay. So you have to practice all the stuff, okay? Simple. Create a repository, generate the token, configure username and password, and see whether it is storing in that user home.git config. And remember this commands: clone, add, commit, push. Any questions for me today? Can stop today's class.
Yes, sir. Have you shared that document so that we can refer that?
Class notes I have already given to you, right? Everybody?
Yes.
Sorry,
You don't
I leave on last 2 days. So I don't have.
Okay, 1 second. I'm sharing it to you.
WhatsApp have the link in WhatsApp group.
Smriti,
Yes.
can you just
Yes, I will again share it.
Okay, thank you everybody. And I hope you are reading that toolkit book and going through the Linux tutorials. Okay. Do that without do that continuously. Thank you. Good night.